In her best-selling book, Braiding Sweetgrass, botanist Robin Wood Kimmerer writes about looking at the world through a scientific lens and trying to find answers to the way that nature works. She finds that her heritage as a Native American and the stories of Native peoples often hold the answers. And often, those answers underscore the need for balance and harmony between people and our environment. When we talk about resilient systems, we're not just talking about our servers, networks, and applications. Our systems encompass the technical resources and the people and teams that build and operate them. The problem is that every day engineering teams are tasked with ensuring that incidents don't happen. They're told, make this application robust, to have ever-increasing nines of reliability, to have zero downtime, and on and on. And yet, we're also told to acknowledge that failure is normal. It's a Sisyphean task that's pushing us all towards burnout. So, how do we improve our systems, both our technology and our people? How do we make our tech more reliable and also have happier engineers, equipped with greater knowledge and expertise? Robin Wood Kimmerer might suggest that when people and nature, and maybe technology, are out of balance, that the traditions and stories from the past can provide some wisdom. Hey everyone, I'm Jason Yee. I'm the Director of Advocacy at Gremlin. I've had a long career in technology, starting as a systems administrator who also did desktop support and managed an on-prem data center, to becoming a full-stack developer and a software engineer. And I've gotten to work at companies like MongoDB and Datadog. I currently work at Gremlin, where our goal is to make the internet more reliable. We do this by allowing you to proactively improve reliability. We create a chaos engineering platform that makes it safe and easy to inject failure and learn from it. But getting back to balance and harmony. In her book, Kimmerer describes how the scientific community is struggling to understand why sweetgrass is dying off. And as they do this, she notes that many grasses undergo a physiological change known as compensatory growth, in which the plant compensates for loss of foliage by quickly growing more. It seems counterintuitive, but when a herd of buffalo grazes down on a swath of fresh grass, it actually grows faster in response. This helps the plant recover, but it also invites the buffalo back for dinner later in the season. The system is well balanced. Why shouldn't it also be true for people and sweetgrass? We are no more than the buffalo and no less, governed by the same natural laws. With a long, long history of cultural use, sweetgrass has apparently become dependent on humans to create the disturbance that stimulates its compensatory growth. Sweetgrass thrives where it's used and disappears elsewhere. The longer that I've been in tech, the more I've seen similarities in Kimmerer's sweetgrass observations. Systems that are static eventually become obsolete and disappear. Applications that are challenged by constraints, faulty environments, or needs to scale massively, those are the ones that evolve and grow. So how do we introduce the right amount of disturbance to our applications and our teams to create harmony and spur growth? I think the answer is chaos engineering. Maybe you've heard about chaos engineering because of Chaos Monkey, the tool from Netflix that, in its original version, would randomly take down servers. That's not quite what we mean when we talk about chaos engineering. Chaos engineering is a process, not about breaking, not about destroying things or wreaking havoc chaotically, but it's about learning. The goal of chaos engineering is for you to learn more about your applications, to validate your mental models, to expose unknown unknowns, to give you a better understanding of your application and the environment it operates in. And ultimately, this better understanding is what leads you to build more reliable, more robust applications. It leads you to resolving incidents more quickly because you know how things truly operate. It leads to lower stress during those incidents because it builds your confidence to make better decisions, and it builds your trust in your teammates. In short, I like to say that chaos engineering is thoughtful, planned experiments designed to increase our knowledge. Or to make it even shorter, I like to say that it's science. And that's how we do it. We follow the scientific method. This happens first by observing the system. And that happens every day as you interact with your applications and your infrastructure and your teammates. You start to get a sense of how everything works together. From there, you can form a hypothesis. How do you think it all works? What are the underpinnings and mechanics? How would this socio-technical system, this combination of people and technology, react to stimuli? That stimuli is failure, so you inject that failure stimulus and take note of what happens. Then you analyze the results to find where your understanding differs from reality. And if necessary, you update your applications or infrastructure to bring them in line with your expectations. Finally, you share your results, not just with your team, but with your broader engineering organization, or even wider, to the SRE and DevOps communities. You do this so that others can learn from what you've done and even replicate your work. There is one non-scientific method step that's completely optional, but I highly recommend it, and that's to celebrate. If everything went according to plan, celebrate. It means that you've got a full understanding of your system. If it all went sideways and maybe it accidentally caused an incident, well, then you resolve the incident first, but then celebrate, because you discovered a risk that could have occurred in the middle of the night with nobody available to respond. So celebrate that you discovered it before it became a major problem. So how do you get started? I've seen dozens of teams successfully doing chaos engineering, and each is a little bit different. But in my time doing chaos engineering and helping others to do it, I've found 3 approaches work really well. The first approach is to validate your understanding of restarts. In other words, if you kill the process, container, or VM, does it restart? And if so, how is that restart handled? This seems basic. You probably have a system daemon or a container orchestrator or VM controller or whatever that will automatically restart things. But I often find that as systems become more and more complex, lots of things can prevent those automatic restarts. Or those restarts can lead to problems elsewhere in a system. I particularly like this experiment because it's a good trailhead and usually exposes many different paths that you can further explore. Recently, when helping a company run a series of experiments, a team validated that their restart process worked exactly as expected, and that was fantastic. However, during this day of running experiments, in a later experiment, the team ran into serious issues with the service until someone recalled that they had that successful restart. Rather than continuing to troubleshoot and dig deeper and try to reconfigure the network to resolve the issue that they were dealing with, the team simply killed the impacted service, confident that the system would start it up with a new healthy instance. This worked, and so they added it to their incident response documentation. It now makes it much easier and faster for them to recover from troublesome issues. The second method is to validate your monitoring. Monitoring and alerting are critical to resilient systems because they provide insight and data. So you need to verify that you can see changes in things like latency, error rates, traffic or request rates, and resource consumption. And then work to ensure that alerts are working as you expect and trigger when intended. I was working with an organization and they were using an experiment to validate their database reliability. At one point, an engineer asked the team, "Shouldn't we have received an alert about this database?" Another engineer took a look and discovered that while the team had alerts when the database had a high number of connections, something that would have created a bottleneck and caused a backlog or a contention with that resource and slowed down the application, but there was no alert if it had an anomalously low number of connections, something indicative of a problem in being able to reach the database. The third approach is to replay incidents. When running blameless postmortems or incident reviews, you often hear warnings to avoid counterfactuals. Statements such as, "You should have done this alternate action," are not useful for learning about an incident. Because obviously, had somebody known about that alternate action or realized that that would have been better, they would have done it at that time. However, chaos engineering is a great way to recreate incidents, and it allows you to test these alternate actions and include them in your future incident response processes if they prove useful. By replaying incidents in a more controlled and much less stressful way, teams are able to learn more and grow their skills. And this happened exactly with the team that I was working with. We had experienced an incident, and while running the incident review, it became clear that a lot of time was wasted chasing a red herring. The incident could have been resolved quicker, but one of the dashboard metrics was poorly named. And the on-call engineer interpreted that data as something else. And this led to investigations in the wrong parts of the systems and led to a lot of confusion, as things never seemed to quite match up with what the team thought the data had said. After clarifying what the metric really was and updating the dashboard for clarity, the team ran an experiment similar to the incident we had experienced. And we were easily able to identify where the problem lay. The results of your improved knowledge ultimately affects the systems you work on. At Gremlin, we recently conducted a survey of over 400 organizations and found that teams that practice chaos engineering are overall seeing increased availability, faster detection of issues, and quicker resolution when issues do arise. In fact, teams that run chaos engineering experiments regularly are reporting 99.9% or higher availability in their systems. So back to the sweetgrass. I used to think about us, engineers, as the harvesters of the sweetgrass, or maybe even the buffalo who came and ate it. And I always thought, how could we be responsible to introduce controlled stress and help our systems thrive? But I think I had it backwards. The more I think about it, I think that you are the sweetgrass in this story. Chaos engineering is really about you. It's about engineers and engineering teams and how incorporating controlled disruption into your work enables you to grow stronger and more experienced and more knowledgeable, and ultimately to be a more resilient engineer.